Hi guys, so another bit of ambulance equipment here. This time we have an RSG CVS012. There is a video, or has been a video, on the MCS32 made by the same company. So we're going to have a look at this, and this one actually does apparently have a fault. Let's just spin that around for the hard of reading. This is a much more, what's the word I want? Complex system. This is designed to be used on larger installs, more along the lines of full ambulance conversions and things like that. Again, it suffers from the problem of everything being crowded together, but our connectors are spaced out a little bit more. So I will actually, before we take it apart, we will power it up just to show you that this one works, and we just want to pick a good ground. There is one in there. And then we can go on one of our channel inputs here, and hopefully you can see there that it is powered up and it is doing stuff, nothing particularly useful. So I thought we're going to tear this one apart, or may not tear it apart. We might have a look to see if we can find out what's up with the siren. Potentially we might be able to do something about it, which will be nice. So let's just get into this first. So we've got a display ribbon here we need to just pop out the way before we go any further. I wouldn't expect this to be massively different. Oh, you've even got an earth, I didn't expect that. Massively different from the MCS32. So we've got a display board there, 74 HC573, I'm not 100% sure what that is, and a transistor which will be driving backlight. Sorry, I'm out of shot. So yeah, there's not a lot on there. There's not really a lot to say about that. There's nothing special or different about that. That's just driving a display, and I think, looking at it, the display is mounted directly. The display is on shock mounts. I've just noticed that. That's a nice little touch. Right, so what have we got in here besides an enormous heatsink? I think that's about it. So our first culprit for a siren issue is going to be that. Now the trouble I've got is I can't actually trigger the siren or do much with this, because once again I don't have the control panel. But my guess in terms of culprit is going to be that. Oh, is that what I think it is? Now there's a chip I have not seen for a long time. That's a TDA 2030. So that's just a standard audio power amplifier. So that's obviously what we're using for our siren. I'm guessing there is an absolute crap ton of MOSFETs under there. I'm trying to decide whether it's worth the effort to actually try and fix it. I doubt it. So this has come from the same place as the last one. This has come from ZT Solutions. So I think what I'm going to do is go straight in for this transformer. So we will check the windings here. Yep. That all looks good. That's good. Ooh. So there we go. That might actually be the problem there. So that winding is good. Oh, hang on. That winding is good. But that winding does nothing. Oh, that's because it's an earth. Come on guys, use colour codes. Yep, so it's not going to be a simple transformer fault. So we need to see how we get into this, and I can see a lot of nuts rather than screws. So I think I am going to need to go and get a nut spinner to get into this. But I don't think this is going to be really much different to the other one. I can see an awful lot of clearly labelled test points. Let me zoom you in, and hopefully you'll be able to see them. So what have we got? MISO, MOSI, NTC, which is right there, reset, the light is actually, it's not glaring for you, but it's glaring for me. Watchdog, MAS, no idea what that is. VSA, SPW, RX, TX. So there is all the test points are numbered. All the if I come down here, all of the pins are numbered as well. Or not numbered, labelled, so we know what they all are. Yep, they're all numbered, as are those. That's actually that's a really nice touch. You may remember, or you will remember shortly, that the MCS32, I really wasn't impressed with the build quality of it, and this looks like a step up. So I'm going to pause you, I'm going to get a nut spinner. So we've got these little washers here that don't quite want to come off, and they're locking everything up. Can't quite get that one. I have just noticed something on the underside of this as well. I'll show you in a second. You might have to kill that washer. Get one. One more there as well. There we go. Centre you up. And there we go, we're out. And we've got another one of those. See this hole on the bottom? Well, it matches up with this, and that is almost certainly the SWD, and that's an Atmel actually. That I wasn't quite expecting. So all our processor goodies are on the back of this. Let's zoom you down again, centre you up. So that is an Atmel 8090C AW128, not sure about that. You can see our MOSFETs are on the back here as well. There's really not much to this one. We've got another Atmel device down there. That's an Atmega. Can't quite read that. I'll pop it down there. But looking at that, I think that's actually just a siren generator. That only appears to be connected up to the audio side, so that could potentially be our siren not working problem as well. Up here we have an RS. Right, sorry about that. Without realising it, the SD card ran out and I didn't get a notification. So we got the board out in the end. We had a quick look at it. So we've got a blown diode there by the looks. I don't know if you see that. Bulge on the top of that. We've got our TDA 2030. We've got two diodes here which are going to be for the headlight type arrangement. We've got two IRF 3205 MOSFETs there. And then a quick look on the back. And we got a couple of little surprises here. So we've got what appears to be our power supply here. We've got our RS485 transceiver up here. We've got various audio bits. That one's marked PTT and that one's marked something else, but I don't think there's a guide as to what they actually are anywhere. So we are that way. Yes, we're that way. Microphone volume, radio volume, handheld connector and CAN bus, so that's what our transceivers are under there. And then we have inputs and outputs. Special function inputs, that sounds interesting. Probably isn't. And then poking around the bottom, I spotted something interesting. So we've got our big Atmel processor right here. I'll pick up a screwdriver. And we've got two separate processors. Now this one is almost certainly generating our siren and controlling the siren. This almost appears to be a completely separate block. And then we've got another one here. I'm not quite sure what that one would be doing. My only thoughts is this might be handling the CAN bus, although obviously this has got CAN support built in. Did we decide what it was? Yeah, it definitely has CAN. 1890 CAN 128S 16AU. So yeah, so our siren problem could actually be this chip. And then we've got our power MOSFETs that drive out these high power channels. It'll be interesting to see what these are, because we're constantly on the lookout for automotive MOSFETs with monitoring functions, and every time we find one that we think will work, it's either obsoleted or becomes obsoleted fairly quickly. I don't know why that is. They are all sat down quite nicely. I thought one was up. We have this lovely bodge here. I'll bring you over. So you can see we've got a ground plane here that comes through, and that feeds the centre pins of these connectors, or does it? No, it doesn't actually feed the centre pins of the connectors. It's supposed to be that top pin there is certainly ground. But if we come over here, this ground plane is actually disconnected. So my guess would be when this was routed, they managed to isolate this polygon, and that's going to affect these four resistors here. These four resistors here, which I'm guessing are pull downs or pull ups. But yeah, it's completely isolated, so we've had to put this in, and I'm willing to bet, looking at that diode there, that's the leg from that diode. They've recycled that. On the inputs and the outputs, we've got the usual protections. We've got diodes and current limiting resistors to clamp everything, so there's nothing unusual there. That's the fan header. These look like they're driving 7.4 series devices, so that will be the outputs and the inputs. Probably a 373 or similar. Can't quite read them. I'll put them in down there when I worked out what they are. We have some transceivers up there, but that's it. This is so much better built than the MCS32, and again, it's a much thicker, more solid board. It's been well thought out. The layout's much better. I think the 32 is probably just a victim of everything being trying to be forced into such a tiny area. And there's our TDA 2030. Anyone that's built audio kits and things of a certain age will remember those. That isolation washer there that's just fallen off is actually melted. So I'm not quite sure what those would be involved with. Possibly switching the siren. Looking at that, that one's switching the siren power on and off. Not quite sure what the other one's doing. Or maybe this one's our siren, because there's the 2030 there. I could probably trace that out and work it out. But then you'd have to wonder what that's doing. That is driving a big high current MOSFET down there as well. Anyway, that's that. I'd say I'm much more impressed with that than I am the MCS32. There's salvageable parts in here that I will lift off and use, and that's certainly going to be useful eventually. That would work quite nicely with a PTC. Not a PTC, a TEC thermoelectric cooler. Anyway, I'll leave you with that. I'm going to make a new coffee because this one is now stone cold, and we'll see what we can find next in the pile. Anyway, take care. Thanks for watching. Bye.